Sanbonani guys, I really hope that you're doing good. So today's lesson is the last one under quantitative aspects of chemical change. So we call this section the limiting and excess reagent. And today's lesson is going to be applicable to only grade 11s and grade 12. So grade 10 is not yet doing limiting and excess reagents until next year. So when they do grade 11. Now let us proceed. The word reagent mean one and the same thing as the word reactant. I want us to have that as we move forward. So it's not a big word. We already know what is a reactant in a chemical reaction. So another word for a reactant is a reagent. So when we look for a limiting and the excess reagent, we're gonna look and try to observe on the reactants side, not the products. Now we're gonna define a limiting and the excess reagent. So what is the limiting reagent? It's going to be a reactant number one that is used up completely in a chemical reaction. So we're always speaking about the completion of the reaction. When exactly is the reaction complete? So a reaction is only complete when the reactants are used up, or at least one of the reactants is used up, then the chemical reaction will be complete. So now that reactant that is used up completely in a chemical reaction, that reactant that stops the reaction from continuing is the one we call a limiting reagent. It stops the reaction from continuing. It is used up completely in a chemical reaction. So it's a very important reactant, this one in this chapter, because it determines the amount of reactants which will be used, that is going to be used. Number two, it determines the amount of products that will be produced. So now how much do we use from the reactants and how much do we produce from the products depends entirely on the limiting reagent. Now let us proceed. The excess reagent will be a reactant that remains after the chemical reaction is complete. It may happen at time that one of the reactant remains after the chemical reaction is complete. So the one that remains, we call it an excess reagent. So now I have this mathematical relationship that can calculate any amount in excess, and I think it makes sense. So now an amount in excess will be calculated by saying initial amount minus whatever you have used. So what you had initially minus whatever you have used will give you the excess amount. And by amount, I'm speaking about the number of moles, mass, or volume. So this can be number of moles in excess equal to number of moles initial minus the number of moles that are used. It can be the mass, it can be the volume as such. I want us to interpret the following graphs just to make sense of the limiting reagent. We have a graph of an amount versus time, and our amount in this case is a mass versus time. Now, a decreasing graph like this one always represents a reactant. Even this one, it represents a reactant. Why is that the case? It's because in a chemical reaction, our reactants are being used up. So the amount of reactants in a chemical reaction will always decrease because we're using these reactants to form or to produce our products. Now, how do you know from this graphical representation that the reactant is in excess or it is a limiting reagent? Now, from this graph, we can see that we have an initial amount. So the initial mass is 30. But here, the reaction is complete. So once we have a horizontal part of the graph like this, we say that the reaction is complete. So now we can see that at the end of the reaction, the amount of zinc remains. So how do we define an excess reagent? It's the reactant that remains after the chemical reaction is complete. So because the mass of zinc remained after the reaction, we're gonna call this reactant the excess reagent because it was not used up completely. We have the initial, we have the final amount after the reaction, and we only used a portion. So when you only use a portion out of the total, you have an excess reagent. So this is how the graph of an excess reagent is going to look like. But if you speak about the graph of a limiting reagent, Remember, we said a limiting reagent will be used up completely in a chemical reaction. So from an initial amount greater than 0 all the way to 0. So there's no amount remaining after the reaction is complete. So this one will be the graph of a limiting reagent. So if zinc is a reactant, it's going to be the limiting in this graph because it was used up completely. We can see that the initial was 30, but after the reaction, the final amount of volume is 0. So we used all of the 30 decimeter cubed volume of the zinc. So it is completely used up. We used the full 30 decimeter cubed, but here we only used a portion. So please have these graphs at the back of your mind. Now let's try to have some interpretations of how we can identify or determine the limiting reagent. Okay, let us say we have this reactant I'm calling substance number 1. It is a reactant. So now, and let us assume that I know the initial or the present number of moles before the reaction. And let us say I know the number of moles that I have used or that I need. So these are the initial number of moles, and these are the number of moles that I need for the reaction. So now, if the present amount of number of moles is smaller than what I need, that means whatever I have will be used up completely. Remember, we've seen this definition. So if a substance is used up completely, then we have a limiting reagent as such. Okay, but let us say that another reactant, S2, I'm calling it S2. So let us assume that we know the number of moles of substance number 2, which is another reactant. So if the initial or the present number of moles is bigger than the one I need, so what I have is bigger than what I need. So that means after using what I need, this substance will remain. As such, we're going to say that substance number 2 is an excess reagent because it remains. But substance number 1 is a limiting reagent because it is used up completely in a chemical reaction. Let us try to do a calculation just to explain what we're talking about here. So we said to determine the limiting or excess reagent, we always need to compare the present amount of moles and the needed amount of moles. So that means our calculations should calculate the initial number of moles or the present number of moles, and we should also calculate the needed or the used number of moles, and then we just compare using this and then come to the conclusion of whether we have a limiting reagent or the excess reagent. Now, initially 3 grams of hydrogen reacts with 67.2 decimeter cubed of oxygen to produce water at SCP. So we know what is initially present before the reaction takes place. We have the chemical reaction that represents what is happening in the scenario. Now, question number 1 says, determine the limiting and excess reagent. So as step number 1, we need to find the present number of moles and we need to find the needed number of moles secondly, and then we just compare them. It's simple as that. So let us find the initial or the present number of moles of let me use the other pen. Let us find the initial number of moles of oxygen. What do we have? For oxygen, we have a volume that is reacted at SCP. So that means we can find this initial number of moles. So we can say the number of moles of oxygen will be V over Vm. So this is how I'm calculating the number of moles because I have this volume at SCP for oxygen. So it is in decimeter cubed. I can proceed. It's a 67.2 divided by the constant 22.4, and this is equivalent to 3 moles. So that means these are the present number of moles before the reaction. We also calculate the number of moles of hydrogen which are present initially before the reaction takes place. what are we given to calculate the number of moles? So you can do anything that calculates the initial number of moles. You can even be given a concentration and a volume, so whatever that can calculate the initial number of moles. You can be given the number of molecules, and you know the formula that can calculate the number of moles there. So now in this case, for hydrogen, I'm given a mass. So to find the number of moles, I'm going to say 3 over the molar mass. So I'm using my formula, mass over molar mass. I've just skipped a step here. So now this will be a 2 times 1. So this value is a 1.5 mole. It's a 1.5 mole. And remember, this is simply the present amount. Okay, after we have found the present amount, we need to calculate the needed amount of each and then try to compare. Now, we are calculating the needed moles of oxygen. So we're simply calculating the number of moles which are needed for each and every reactant that we have here. You don't have to do two calculations. One calculation can either prove a limiting or excess. Okay, but I'm just going to do both for control's sake. So now let us calculate the needed number of moles of oxygen. If we know the number of moles of hydrogen, we already have the present. We now need to calculate the needed number of moles. So this is going to be the number of moles of substance number 1 over R1 equals to the substance number 2 over R2. So these are our substances, of course, the ones which we're trying to prove as either limiting reagent or excess reagent. So we're calculating the number of moles of oxygen. That means my assumption here is that I don't know the number of moles of oxygen because I'm calculating the needed moles of oxygen if I know the number of moles of hydrogen. So from the calculation above, we said hydrogen is a 1.5. So I'm going to say a 1.5 divided by 2. So we can see that this number of moles are 0.75 mole. And these are the needed. These are the needed. So now we have the number of moles present for oxygen. We have the number of moles we need for oxygen. So which ones are bigger? So the number of moles of oxygen which are present is 3. And the number of moles of oxygen which we need is 0.5. So we can see that the present amount is simply greater than the amount of oxygen that we need. We said if the present amount we need is greater, therefore oxygen remains. So oxygen remains, so therefore it becomes our excess reagent. Okay, oxygen becomes our excess reagent, and by default hydrogen will be the limiting reagent, but one person can prove with that calculation. Okay, so you can either calculate the number of moles of oxygen if you know hydrogen, or you can do it the other way around and calculate the number of moles of hydrogen if you know oxygen. So I'm using the same formula, but I'm going to do a different substitution. Now, I don't want to substitute for hydrogen. I want to substitute for oxygen now. My assumption is that I know how much I begin for oxygen. So the initial amount of oxygen is a 3 over 1 equals to the number of moles of a hydrogen and then divided by 2. So now let us cross multiply here. So the number of moles of hydrogen will simply be a 6 mole. Okay, remember these are the needed amount of moles. So this is what we need. So let us compare again. Let me bring back this. So now we're simply comparing the present for hydrogen and what we need. So we can see that our present is smaller than what we need. So the number of moles of hydrogen which are present, they are smaller than the number of moles of hydrogen that we need. So for this reason, we said when the present is smaller, the substance we're talking about is going to be the limiting reagent. So in this case, hydrogen is a limiting. for this reason. Okay, but let me just summarize it like this. Once you prove one to be the excess, that means the other one becomes the limiting. Here, if you prove that hydrogen is a limiting, that means oxygen will become an excess reagent. So you can either do a calculation of oxygen or hydrogen of one of the reactants, but both of them should come to the same conclusion, that one substance is a limiting and the other is the excess reagent.